So, hi guys, my name is Hermes Bonilla. Before I share the slide deck and everything, and we get right into it, give you a little bit of an introduction to myself, because we're going to be going into introduction to machine learning. But I guess you kind of want to know who I am, hopefully. So my name is Hermes Bonilla, and I'm from DSC. So I'm all the way in Miami, Florida. And welcome if you're from Canada or from Miami or from anywhere. Welcome. And I'm still in high school, so it kind of makes sense. Kurius helps high schoolers and other students. And I'm finishing my senior year now, but I'm in dual enrollment, so I have a little bit of college experience, about 2 years. And currently, I went from machine learning tech lead at DSC FIU, and now I'm going to be one of the VPs. So great to be here. I hope that tells you a bit about myself. If you have more questions, feel free. Right, so let's get started. Let me share my screen. Great, so I'm going to be using a slide deck. Normally I make my own slides, but I really like this one. This one's from Google AI, and it's for DSDs and so on. This is Introduction to Machine Learning, and yeah, we'll get right into it. Most of this, we're just going to go slide by slide, but I want to start off first with a video because it's from Oxford Sparks. It's great. I love it. It's a really good video, so I'll let it speak for itself.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognize a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organizing it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit Oxford Sparks.
So I love that one. I love their animation. I think it's super cute, and it gives a really broad overview of machine and some of the applications, which we'll talk about in a bit, probably towards the end of the kind of like the middle to end portion of the workshop. But hopefully you got a bit of the gist of it. And yeah, let's get to our next one. So we're actually gonna do a game, and this is it's gonna require like some engagement, so feel free, but this is a game from Google AI actually, and I'm more of a visual learner, so I personally love this, and I think it helps teach it really well. So let's see, this is quick draw, and let's says, can a neural network learn to recognize doodling? So if you played Scribble.io, this is kind of the same, but what it's going to do is it's going to, we're going to draw something, and it's going to try to recognize what I draw and try labeling it. And if it's correct, it'll go to the next one, and we'll see. So as a warning, I'm terrible at drawing. If it doesn't recognize it, it's not because it's not a good system. It's just I'm terrible at it. So we will see. We'll see how it goes. A pig. Okay, that's not the easiest one, but let's see. Let's see how it goes. Oh,
I see line, or knee, or boomerang, or tooth, or bread. I see circle, or bear, or steak, or avocado. Oh, I know, it's pig.
Oh, okay. So it recognizes quite fast. I didn't even finish the eyes. But you hear it as it's what I love about it too is that you hear it trying to guess what it is. So it's like, I don't know if you guys can hear the robotic voice, but it's saying like, oh, that's a line. Of course it's a line. But yeah, so we'll see until it matches it. If it can't match it under 20 seconds, it'll just say I don't know. So a harp.
I see line.
It's not easy.
I see golf club. I see foot. I see shoe. I see pool, or pillow, or bread, or glove, or book. I see hot dog. Oh, I know, it's harp.
Oh, okay. I got scared there. I didn't know what to expect, but okay, we got that one. Let's keep going. Penguin.
I see knee, or street light, or bread, or flamingo. I see paperclip. I see sleeping bag, or fire hydrant, or soda can. Oh, I know, it's penguin.
Okay. I must say that penguin. I hope that was a good one. But let's get to newspaper.
I see line. I see elbow, or leg. I see arm. I see hexagon, or bow tie, or passport. I see book. I have no clue what you're drawing.
Oh, that is not.
Oh, I know, it's newspaper.
Okay, it guessed it. So far we're 5 out of 6. It guessed it. I think I can do birthday cake. Thanks, Fred. Yeah, I know my penguin skills. Everything else is bad, but penguins, you gotta love them. But as you see, it's kind of like it's guessing what I'm drawing, and if you think about it, it's really incredible because to us we recognize patterns. We can see, okay, that's a penguin. That's kind of a harp. I'll let it slide. That's newspaper, but to a computer, it's just pixels. I mean, it's pixels on a screen, and if you go a bit broader than pixels, and you start, it might look like, okay, those are lines. So, and we'll talk about how it learns and why it can be better than just normal coding, like without any AI. Let's do birthday cake, and then we should be good. So I'm gonna draw.
I see knee, or shoe, or moon, or circle, or pond. I see hockey puck. Oh, I know, it's birthday cake.
Okay. Well, one more, and we should be good to go.
I see line. I see elbow, or foot, or shoe.
See.
Oh, I know, it's roller skis.
Yes. Okay, I got all of them. That's very surprising. I've done this before, and I did not get all of them. But okay, let's see. So it's saying, it figured out 6 of the doodles, and you have like it shows you the pig, the harp, the penguin, and it looks more like a popsicle. So I didn't get to draw the feet. Newspaper, birthday cake, and roller skates. And he's able to quite quickly recognize all of them. I think the slowest one was newspaper. And that could be because, you have books that look the same. You might have a paper that looks the same. And Fred says, does it have a limited amount of prompts it can give, or is it random things? So it does have a limited amount. Not to a point where you'll get repeated ones. I think you can play this game for a very long time and not the same exact ones. But it's not, for example, scraping it off the web and being like, okay, let me find all these words. They do have class is defined, because you need that for your model and for the website too. So, but there's a very broad range of prompts. Like you can see, I mean, these aren't related in any way. Pig, harp, penguin, newspaper, and birthday cake, roller skates. How it figured it. I've never done this part. I didn't know that this was. Wow, we're learning something. I didn't know you can click on it to see what it was trying to recognize. So it actually, so these are some that are similar, and you can see it's kind of similar. Our drawing are in the back, and wow, this is cool. I didn't know this was here. I kind of lagged to make too straight of a line, so props to them for figuring it out. But you have power outputs close and donut. So this is a pretty good guess. And these are some other examples from pigs from other people, and I'll show you some of the data. By the way, this is beautiful. Like, too bad they ran out of time, but we got some artists here. And yeah, so these are just some examples that other people drew, and I'll get right into it. Let's see. Let's get right into the data, and let's see how that goes. So this part is cool, and I hope you can see. So let's pick one of these. So I see the apple actually. So let's get into the apple, and then the cannon, wherever that is. So here we have 1,390, 1,039,898 apple drawings. So this is part of the data that we're training our model on, and that's one thing that's particular about machine learning. I'll get into it a bit more, but you feed it data, and it starts to recognize patterns. So, like for example, for apple, how does it recognize an apple that somebody else drew? Like you have an apple here that is that has a bite out of. I mean, how do you recognize that from an apple that doesn't have a bite? And by training it all these examples, it actually gets better with more examples than you give it. Like you have the Apple logo right here. Hopefully we don't get copyrighted. But so you have all these drawings, and actually it's really cool. When you hover over, you can see how people drew it. So I don't know. I think it's a pretty good feature. You don't need that for your model. It's not going to feed it how people drew it. It's just going to feed it the final product. But yeah, and further, is it still learning when you play, or is it like finished? Actually, that's a fun thing about this. So they're constantly connecting data. So for example, if I keep playing and I get apple, this will actually update. This would be 899 apple drawings, and it would actually feed it part of it in our model, or in their model in this case. So it's constantly learning. As people play, it gets better at recognizing. So I don't know. I find that that's super cool. And so could you gradually change it? Yes. So for example, let's say I'm devious and I somehow get apple over and over again, and I draw a banana instead. Luckily, we have a large pool of data that it's training on, so it wouldn't skew it as much. It wouldn't start badly recognizing it as much. For example, I get 50,000 apple drawings, which is a really big number compared to our data. We'd actually start seeing changes. It's going to get worse at recognizing the apple, because it's going to include the banana as part of, okay, this is an apple, which is really funny because, for us it's obvious, but so you could skew this data. Luckily, there's a lot of data for it, for all of these categories, and it shouldn't do a big problem. But I think you can also flag something's not good. But also, a feature is when you click, you can actually see where it's from and what date. This is from the United States. Here we have from Korea, from the Republic of Korea, from the United States, from Russia, from Ukraine, Australia, United States again, United States, a lot of US, but yeah, that's pretty cool in my opinion. How do you program it to learn? Actually, so that's part of creating a model, and so you have to code it, you have to program it, and what you're doing is you create some kind of, we call it a pipeline. So you have, it's a system that, for example, you have a pre-processing part. You have to make sure that the data that you're feeding in, for example, we can't tell our model, okay, have at it. Our models work with more mathematical terms. So an image, and I won't go too much into this because I don't want to confuse you guys, or kind of scare you guys. But an image is just, think of it like a bunch of values for pixels, right? If you have like black, it's going to be a lot of value in that one pixel, right? And so what you would do is you would actually flatten the picture. So think like you're cutting up and you're pasting it next to each other. And then you're feeding that. So you're feeding in like in an array, which if you don't understand, don't worry about it. But you would do something to that picture or that image, and then you're able to feed it in the model, and it starts to learn from it. And we'll quickly go into the repo. This is the GitHub repo, which I started because it's great. And here they actually they let you use the data sets if you like. So if you'd like to train your own model, you could based on this if you don't have to do it. And here we can actually see the array. And yeah, so they explain a bit about it, and they show projects that have used their data that they're creating, which is great because it's open source, and the data that they create, which is constantly growing, it allows people to do other cool projects with. And one that we'll look at is, let's do Misfire.io. So it's a really cool project. Check it out after the workshop if you'd like. And let's start guessing. So this is the reverse. So like for this one, I might guess popsicle, which is, do not roast me on that. Syringe. Okay, that one is kind of hard. But it's saying I'm not better than the neural network. But let's see if we can guess. This is a squirrel. I bet. What? What? Okay, so you see, this is part of incorrect data. Somebody misunderstood. They're from the Netherlands, which they speak Dutch, which I also speak. They're from the Netherlands, so maybe the language barrier got to square. They thought squirrel. So this could happen, and since you have a lot of data for your model, it's not that bad. It won't affect it too much. Let's do one more. This should be the sun, if it's not another mistake, I hope. Okay, I got scammed there. Again, I think a language barrier, but when you guess it right, it should say that there's some hope for humanity. That you can beat a neural network in that particular aspect. So yeah, we'll get back to our presentation, and I will click this. Yes. So we talked about some of these, and we can go a bit further into it. But let's first talk about what is rule-based kind of classification. So what we have, if you code, and if you don't code, don't worry, don't get caught up in this syntax. Although it's Python, which is a great language. I recommend it. Most of AI stuff, machine learning and everything is done in Python. So if you're interested in that kind of stuff, you might have to learn Python. But anyways, don't worry about the syntax. All we're doing is just to show. So if we're doing this in a rule-based fashion, which is in coding, we might say, well, okay, let's say we're getting a carrot, right? And we're trying to get a model to recognize a carrot. So we might say, well, if the object, the height, let's get the height, that's 10. And let's say if it's blue, do y, which we could say like, okay, take some points off being a carrot, because carrots normally and not blue, right? And number of legs and so on. So we'd have to define so many if statements to, in the end, maybe not even get it correct, right? Because there's so many variations of carrots and how people draw it. And I'll show you in a second. Um, that are we can have a perfect like, 1,000 line if statements, and it still might not even get it right, even though it's the object that it is, right? Because our brain doesn't have that where it's like detecting. Our brain works. I mean, AI is kind of modeled after neural networks, which is our neural our brain. Um, but so you can see how it can get really long very soon and kind of difficult, right? And inaccurate. But what if we do with machine learning? So with machine learning, we're training a model based on examples. So we're not doing if statements, and we don't need to say, well, if it has this length or if it has leaves, here we can just let our model train on this data. So we have these carrots, and as you can see, they're all different. I mean, there's not one that's identically the same. Which, if we do in rule based, we can we might not be able to identify that any of these are carrots because we set a set of instructions rather than, well, here are the examples and figure out how it should look like. And here we have a drawing which it correctly matched as a carrot. And this kind of reflects to how we learn, because we're not told like a set of instructions, learn by examples. Like, oh, okay, this is what a book is like. Well, let's test it. So let me know. So which approach should we use when alphabetizing a list of song titles? But okay, so we're seeing some R's. Let's check. Uh, yes, this one is better rules based. And the reason for that is with song titles, you know that they're going to be somewhat in the same fashion. So you could say like, since it's alphabetizing, you could say, well, if A, put that one first. If B, put that one second, right? So it's easier to do rules based than machine learning, and it's the most efficient approach. Ranking web search results. What are we feeling? RM. Like when you search something on Google, how does it rank the most applicable website or most applicable answer to what you're searching for? I see some M's in where Leo put. I see some R, some ML, some ML. Okay. Well, okay. I did trick you guys a little bit. I'm sorry about that. But you can use both actually, and you can use them in conjunction. Um, because ranking web search results is highly complex, and that's how nobody really knows how Google ranks their web search results because it's so complicated, and of course they keep it very secret. But you'd have you can have rule based because you can say, well, based on if I have 20 hours on YouTube in carpentry. I don't know where that came from. I don't do any carpentry, although it's pretty cool. But maybe I'm more likely to get this type of result, right? But we can also use machine learning to start learning personally what somebody prefers. So like with songs, right? If you can have you can use machine learning to kind of group what you like and have a more accurate results, or you can group. I'm trying not to go into the details yet, but you can let me see, how do I put this? Well, there's a lot of different techniques in machine learning, but what you're trying to do is you're trying to learn by experience. You're trying to give data, like data on me, on what I've been searching in the past. So yeah, let's go to the next one. So predicting housing prices based on location. Okay, I see M, I see ML. deep learning. Okay, I see. And ML. Okay, pretty cool. Pretty cool. Let's see what you guys did. I don't see any R's, but not popular. Yes, machine learning. It's easier because you have all the data, which is the housing prices, and you're able to um, get a model to understand what the next housing price might be like based on what you give it, right? So that's good. Let's do processing online payments. Okay, now I'm seeing more R's. Wow, we're getting let's see, rule base. See, yeah, rule base. Wow, you guys are good at this. I could tell you when I started out, I would not guess any of these. Right. So maybe you guys have some experience, but this is really good. Yeah, you want this to be more rule based, right? Because you want everything to be processed in the same way, and it's quite easier just to do rule based rather than machine learning. So it's not that you can't use machine learning, but it's not the appropriate approach to use. So let's see, last one of this, classifying an object in a photo. What are we feeling with this one? Okay, we're feeling some ML. ML. Hey, if you're feeling rule based, go ahead. Don't be ashamed to put any answer. We're not judgy today or ever, right? We're getting a little ML. Okay, let's see. And yes, ML again. I'm really surprised. I don't know if I saw anybody who's wrong. If you did, again, not an issue. But wow, you guys are impressive. Yeah, we have machine learning. This is a classic problem. That I mean, this kind of what we just did, right? Classifying an object in a photo, except that's a drawing. And so classifying an object in a photo, um, I'll get into it in a little bit, but basically rule based, the part that machine learning does much better than rule based. I'll get into my next one. The part that machine learning does a lot better than rule based is it can handle different types of data. And I want you to think about that. It can handle different types of data and still have a good result. Because if we're having something that has a lot of different variation, like images or drawings, right? Um, but we want to classify it as something, or we want to do something to it, but we need to know that it's there, right? This is something that's really difficult with rule-based approach because you're making the rules, so you're kind of assuming it'll be in one type, rather than machine learning that learns the patterns from the data that we get. It's learning whatever you want it to learn through examples, and like some of you guys pointed out, it can improve from additional data, right? Which is it's a great thing because with rule based you have to go and code it back up, but with this you just feed more data. So okay, and as you saw, it's not that one is better than the other. It is sometimes better in some cases, but they both have their benefits and they both have their cons, right? Okay, and let's get to our next one. So I'm not going to talk about this as much as the rest of the things. This is still pretty important, but for our workshop, it's not the most important. Um, and so I'm going to skip around a bit on this one. Just follow around with me. So we can talk about this slide though. The machine learning process. Again, this doesn't apply too much to us yet because we're learning. We're not looking at how to implement it yet. But if we were, you'd think about your user. You'd define some kind of objective. So like it could be okay. Well, we want to predict our housing prices. So that could be an objective. Then we need to collect it. How do we get these housing prices? How do we get these pieces of data, which in our case would be okay, one house with some specifications, maybe the size of the house, so on, and then the location, which is one of the prime things that we're trying to figure out. Then we want to train and test our model. So this is the part where you feed it your data and you see, okay, does it work? And then we have our predict and evaluate. So here is kind of the piece that it's like the fork in the road, because you have to figure out, okay, well, did it do a good job? Did it do what we wanted to do? If if it does what we want it to do, but it's not good yet, we might go back to collecting our data. We need more data because it's identifying our apples as oranges. We need more data on apples because we're trying to figure that, or you might go back to scratch and see if there's another way or another method that you want to use instead. And that's kind of our process. But okay, so let's get into what can machine learning do. We talked about some of the applications, but let's get a bit deeper into it. First, we need to define where machine learning is and what are all these terms I keep hearing, right? We have AI, which is short for artificial intelligence, and think of this term as the big umbrella term. This is the term that covers all of the topics like machine learning, deep learning, and all of its branches, right? You have a lot of different branches, but basically in artificial intelligence, we're trying to get technology to perform a human task, right? So that could be anything, and it's really trying to mimic human intelligence, but artificially. So like through a computer doing. And then, so machine learning is a specification of AI. So it's part of AI, but it's more specific as you're trying to get a machine to, again, do something that a human would do, but you're doing it through feeding it examples and data, right? So it's learning from experience. And that's what we call it machine learning. Because as funny as it may seem, you might think of but you might think of like a robot learning in school or something. But it's your machine, your computer, and it's learning based on experience and data. And then you have deep learning, which isn't even, to be honest, this is my favorite part. But it's a part of a branch of machine learning. So you have AI, machine learning, and deep learning, as you can see in this beautiful graphic. And so deep learning, and we're not going to too much deep learning. We're going to touch on it a little bit, but it's a bit more complex, and you can start having what I if you guys remember, the neural nets kind of of your brain, and you have some really cool ones. Like for one that I deal with a lot is called a convolutional neural network. Sounds super complicated, but just think of it. This is what we normally use to identify objects in images, right? It's actually its structure is meant to reflect our human eye. Like the researchers who created and proposed it, they looked at an eye structure to get it. So, but that's AI, ML, and DL, so deep learning. So let's get into machine learning still. So we have our big data, we have our algorithms and technology, and machine learning is just a mix of that. It's right in between all of that. It handles big data, as you saw, 140,000 and so on. Deep learning handles even bigger data. I mean, we can talk about the hundreds of thousands to the millions of certain data. So it can get much bigger. And let's get to the next one. So let's talk about some parts of machine learning. That we have is classification. So this is a pretty useful one, and it's one that we use all the time. And as you saw before, classification can be used for like images. So maybe I want to classify this image of a lion. Maybe I want to classify it as, okay, I want to know if it's a lion or not, or I want to know if this is a mammal, or I want to know if this is wildlife. So um, as you can see, it can be pretty useful. And we have a graph here, and we have a really good graphic here um, that plots some points, and you might have some kind of distinction, like the line we just drew in the graphic. When you get more points or more data, and you plot them where they are, don't worry, I won't go too much into math. I know I just had finals. I had finals week. I don't know about you guys in Canada, but my brain is dead. um, so I won't go too much into the math, but you can plot these points of data, and based on this line, it could cut off the point. Like, okay, well, this is a line, or this is not a line, or you know. So then we also have regression, which regression is used all the time. But one of the ways that we can see where it's really useful is we have regression, as you can see in the graphic, and these are points of data. They could be anything, housing prices and so on. You might be able to use regression. And what we're doing here is, if you guys your high school classes, or maybe in college you still talk about this, you have your almost like the line of best fit. So you have all your points, and then you make a line out of that, and then you can predict from that. You can say, well, I can predict more or less where my point is going to be, right? But we can also use this, as you see below. We can use this regression system with distances and with maps to say, well, okay, this is the fastest route, or it's a bit different because you have to make sure you're you're being legal and driving on the road. You can't just like go through a mountain, right? Maybe with a plane, this is better, but again, you have air spaces and so on. So, but we can use regression here, and if you guys drive, I guess you use regression all the time without even knowing. So yeah. Next one, we have our clustering, and this part's really cool. So one of the first data sets that a lot of people work with in AI, and listen up if you're interested in getting into AI, which I'm guessing if you're here, you must be. One of the first data sets you kind of go into is called MNIST. So you have the MNIST data set. And what this data set is some researchers, very good idea, by the way, they decided to do the hand-drawn numbers from 0 to 9. And they made this data set, which is called the MNIST data set. And from this data set, you can actually train a lot of models to, for example, recognize certain numbers. And just like when we were drawing our apples, our mustaches, our dogs, excuse me, just like we were drawing them, we can do the same with numbers. Because let me tell you, my two might look very different from your two. I might do a little buckle, and you might just kind of like this one, right? And my sevens, I always draw a line right here on my sevens, and you might not. So we might want to use clustering, where it clusters, and you have this awesome graphic. Obviously, when you're doing your model, you won't see it going like this, right? This is just a visual, but you cluster your data, which in this case is the hand-drawn numbers, and you cluster your data. Sorry, I was just thinking, like, somebody should do it for letters if they haven't already. But you can say, well, okay, these numbers look the same, which in our case could be our sevens. They look very similar. Cluster them, and you could say these twos look the same. Cluster them, and make some kind of distinction. What am I clustering in on? So based on that, like the the graphic on the top, you could say, okay, well, use this kind of cluster. If a data point ends here, it's part of this cluster. So if a data point lands in my sevens, it's most likely a seven, right? And you can have incorrect ones, but a good model, you'll normally get it all right. And so this is really useful, and we use it all the time. Let's see. So next one, sequence prediction, and we're almost done with our types of machine learning. But this one, I love this one. I don't know about you guys. If you have an iPhone, they recently added this. I don't know how recent, but they added this. I have a friend who had an Android, and he said, "Well, we've been had this. we've had this forever. You guys are behind." Referring to like people in Apple. But I'm guessing most phones now have sequence prediction. But this is a type of machine learning, and you can have it checks your spelling for you, or it might estimate what word you're going to write based on the previous letters. And so what you want to think about with sequence prediction is it's thinking about what you did last, right? It's doing it in a sequence, hence the name. A lot of things are named very, very well. Once you kind of get the terminology of it all, it makes a lot of sense why they named it that. And sequence prediction is one of them. You're going in a sequence. I'm predicting something based on a prior action. We're gonna have another a quiz. And this one's a bit more difficult in a second, so I think you guys will be able to do it though. Okay, so let's see. Let's go to our next one. And this is the final one that we're going to be talking about. And this is style transfer. So as you see, there's a turtle, and you have a wave, which I love that artwork. It's, if I'm not wrong, it's The Great Wave of Kanagawa by Hito. And I got to remember his name because he's a great artist. Hitosuke. But yeah, it do be tough. But I love that drawing, and I might be thinking, well, I want to take this image, which is a real image of a sea turtle, and I want to take that, and I want to take the essence of it. I want to take the essence of the art, which has a very cool art style, in my opinion, and I want to put it on the sea turtle. For what reason? I don't know. I like it. Sometimes you don't need to really have a reason, right? Except that you like it. And as you see in the little GIF, it's taking that image and it's putting kind of style to it, right? The style from the artwork, and we can do that with AI in general and machine learning. So let me see. I should do this for me. Yes, this would be cool. There's a lot of people who do style transfer. So there's some interesting useful applications to it. Like I saw some, because it doesn't need to just be art. I could be taking, there's one, and I wish I had that link for you guys. It's a GitHub repo, and what they did in their project is they would take, for example, they would train a model, and they would take a let's say a house in the snow. It's kind of dark, right? And let's say that's our second picture, and we have a castle, and we're like, okay, well, I want to have this castle just like I want this turtle. I want to have this castle, and I want to add this snow thing because I think it'll look better. It actually, surprisingly, you can have some really good results where, for example, the castle will look a bit darker than it did before, and with snow. And what we can see is with style transfer, we can do this with voices and audio, which is actually, this is part of what I'm researching. I didn't say this, but I've been researching for like a year and a half. I lead a research team of undergraduates. And what we're doing is with audio deepfakes, and don't worry, I won't go much into that. If we have some time after and you guys are interested, I can talk a bit about that. But you can use machine learning and deep learning methods on audio, because as long as you can be translated to numbers, you can use it, as long as they have some kind of meaning, and gets a bit more complicated. But really, as a good rule of thumb, as long as you can turn it into numbers, you can pretty much use it. And so we can use style transfer to have, let's say you have an English mail. That's what EN stands for. You have an English mail, and we're doing like Siri, right? You don't want to go. There's so many accents and there's so many styles in the world that if I get one person to use all the voice dialogues that I need to be able to have Siri, if I were to do that for every single accent that I want, like with Apple, if you see Australian male, Australian female, to get all of that, it would be so much money, so much time, and a lot of effort, right? So instead, I can get, for example, excuse me, for male, I could get an English male to have all the dialogues that I want, and I can use style transfer to, excuse me, to say, well, okay, let's let's um, let's get this voice and turn it into an English female voice, right? And then you could do the same, and then JP stands for Japanese, so you can have the same thing for Japanese male, and like that. Of course, there are varying degrees, but you can get really good accents, um, just based on that. So I think that's super cool. So let's see, what type of machine learning would you guys use to recommending what someone will download based on previous purchases? Hmm. So we have classification, clustering, regression, sequence prediction, and style transfer. Bumblebee says people are going with sequence prediction. That makes me question my classification hunch. Well, let's check it out. Sequence prediction. Sorry, Bumblebee. But hey, don't. It's completely fine. And classification is a really good guess on that actually. But the reason for sequence prediction is the keyword previous purchases, because we're um, we're getting we're recommending something based on previous purchases, right? And you're using the sequence because it's prior, then what will they say next, or what will they do next, right? Sequence. And Leo said, I think both actually. It's possible you could, but the best way, and I think it's possible to do the classification. It's just the most efficient way, sequence prediction. Let's see. Let's get to our next one. We're getting some classification. Let's see. Um, yes, it's classification. So you can have you can kind of map out the words. So like spam or not spam. They actually do use machine learning, and I had a friend who one of the projects he did, he actually did that. He really liked it, so I'm sure it's pretty fun. But um, what you can do is it's based on what words you use and in what order and so on. So it's a bit complex, but we can use classification for this because we can kind of think about with classification you're doing some kind of threshold, some kind of boundary. So sometimes it could just be a line, but you're saying, well, um, my boundary between this is like, okay, this is either spam or not spam, right? We have to use classification for kind of binary, spam, not spam. And it can be based on the threshold. How many times is credit card repeated, or how many times is give me your credit card repeated? That should be a pretty easier one. Okay, let's get to our next one. And I'll give you guys a little less time for this one, but let's see. Identifying trends amongst a group of people who have bought a new music release. Okay. So we're trying to figure out the trends based on people, a group of people who have bought a new music release. What are we thinking? Let's see. Let's see. We got some clustering and regression. It was clustering, but hey, don't worry about that. The key term here is a group of people, right? Remember, with clustering, we're grouping things. So we're grouping based on song taste, right? Okay, let's go right to the next one. Captioning a video. Let's see what do you guys think? This one's tricky. Actually, I think the first time that I saw it for this, I don't know if I got this partly right or not right. So this one's difficult. So we're getting a lot of style. And see, it is style. I'm impressed and surprised. I did not get this one right when I first did it. But maybe this is really good. Maybe I'm explaining it well. I'll take it as a compliment. But yeah, really good. So it's style, and this one's a bit confusing, but you might you're taking the input, which is the sound, right? And you're trying to get it to caption. So you want to get the style, kind of like what we talked about before with the voices, and getting it into actual words, which I think is one of the most applicable ones. You know, if you watch YouTube, then you see this one all the time. Next one, give you guys a few seconds. Identifying famous landmarks in a photo. So we have classification, and then style and class together. I see. I threw you off with more than one answer, but let's see. Identifying famous landmarks in a photo. So classification, and I don't blame anyone for being wrong on all of these. I feel like they're so difficult. The Google people are really good. But you have some kind of like discrete label, right? You have like Eiffel Tower, the Great Wall of China, or I don't know, the Big Ben, right? And so you're classifying from this image, like with the line, right? From this image, we have a lion, and then from this image we have this kind of landmark, right? I hope that makes sense. So I'm not gonna review. I think we've reviewed all over the entire time, and you guys have done really well. So what I am gonna do though is give you guys some links, and I'll explain the links if you guys are interested. But I'm really impressed how well you guys did and everything. But I will put this there. So first off, Kurius. I mean, thank you very much for this collaboration. This was a collaboration between DSC, FIU, and Kurius, and we love what Kurius is doing in Canada, and we think it's really admirable. I'm gonna go back to seeing your profile pictures. I can finally see it again. I think it's really admirable. I'm sharing my screen. There you go. I think it's very admirable, and really appreciate you inviting me to come talk to you guys. I hope it's been really insightful, and kind of motivate you to keep going and to kind of look at ways to apply it. Fred said, great workshop. Thanks so much. And my pleasure. I love teaching people what I do. I hope I taught it well, and that you guys are a lot better. You can tell everyone, be like, yeah, I know a little bit of machine learning. And hopefully you guys do some projects along the way. On the GitHub that I linked, in some of the weeks, we actually go over some of the codes and some of the libraries that you guys will encounter. So that might be helpful. If not, there's YouTube videos all over. So my brain is now lightly less smooth. Yes, I felt that. So from smooth brain to big brain. But yeah, anything else before we end the call?